this video, we are going to start with revision exercise 6, differentiation. You will find this on page 306 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. I want you to stop the video and I want you to do 1, 2, as well as 3. In the next video, we will do 4 and 5. As soon as you are finished, you can continue the video. Let's start with number 1. The equation of the curve, and let's just write it down, is equal to 6 over 5 minus 2x. Okay, let's start with number A. Calculate the gradient of the curve at the point where x is 1. Okay, as soon as you see gradient curve, differentiation. Be careful, because if you differentiate this, you must first take it to this form and follow the chain rule. And in this video, I'm just going to focus on the short method of the chain rule. Can you still remember? It's dy over dx. I differentiate the outside and I multiply it by differentiating the inside. So 6 times, it's going to be negative 6. And then I rewrite as it stands there. And I multiply the inside, differentiating the inside. Okay, so that is going to be 12, and it's going to be, if I take it down, 5 minus 2x, and that is going to be my answer. I forgot. As soon as you differentiate, it's multiply and you subtract 1. Sorry. As soon as I wanted to write it down, I realized I didn't subtract 1. So it's negative 2. So I differentiate the outside, negative 1, negative 1, negative 2, and then it's going to be a 2 there. Okay, I hope you picked it up. Now, I'm going to say at x is equal to 1, dy over dx is equal to 12, and now I just substitute the 1 in. And that's going to be 12 over 5 minus 2, that's going to be 3 squared, and that's 12 over 9. And if I simplify that, it's going to be 4 over 3. Okay, so calculate the gradient, that's what the gradient is going to be. Now, number B. Now, number B, it's going to do with that connected rate of change, and you can go back. I'm just checking quickly if I can see the page. Connected rate of change, page 280. You can just revise there, page 280. There we did that. So point with coordinates x, y moves along the curve. So they're referring to this curve at such a way that the rate of increase of y has a constant value of, that's the increase of y, very important there, of 0.2 per second. Find the rate of increase when x is 1. Now you have to make the connection. We already worked out when x is 1. So basically, we are going to, and I'm just going to show it now to you, at the x, we're going to work with the equation dy over dx. That's the differentiated equation. But I want to show you at the end, we want to get dx over dt. So find that increase with x. So we are heading towards dx over dt. But we have that dy over dx at the point is going to be 4 over 3. But now the increase of y as per second. So meaning that dy over dt, that time, is 0.02. I want to try to get this. Now, how will I get this? In order, basically, what I want to do is I want the y's to cancel out. Now, at this stage, will it cancel out? No. But if I change this around, if I make it dx over dy, which is 3 over 4, and I have my dy over dt, which is 0.02. Now, let's just do then that chain rule. So, let's just go and say dx over dy. I'm first going to show you dy over dt. The y's cancel. Do you see? I end up then with dx over dt, the one I want. So basically, I must just go and take this. Now, after I turn it around, the 3/4, this is what it's there, and I multiply it with the 0.02. And if I do that, I get 0.015, and that's dx over dt. Okay, and that's the way you do it. Okay, let's just go on. That was number 1. Let's just make it a bit bigger. We can see better. Okay, let's go to number 2. Want to move it down? Oh, yes, that's the whole number 1. Now number 2. The diagram shows the curve. There is the curve. And the points. Okay, I can see it on the curve. Tangents are drawn to the curve at the point P and Q. Find the acute angle in degrees correct to 1 decimal place between the two tangents. So basically, I'm going to differentiate. I'm going to find this tangent, and then I can find the angle in between them. Okay, so let's just start with my formula. So what is my formula? Equation y equals, and it's going to be 3x plus 1. And again, I'm going to get it in the correct form. And in the correct form, it is 3x plus 1, and that is to the power of a half. So before tangents, that's always with gradient of a curve, and that's differentiation. So dy, and again I'm going to do the short way. So I'm going to differentiate the outside, and remember to subtract the 1 this time. Okay? So if I say half minus 2 over 2, it's minus a half. And then I multiply by differentiating the inside. So I'm getting 3 over 2, and then I'm going to get there my 3x plus 1. Okay. Now, this is my differentiate. Now I'm going to start, and let's do the first one. Gradient, gradient of tangent at P0 and 1. So what's the x value? It's 0. So I'm going to just say, okay, that is going to be equal to 3. And in the place of x, I'm going to put a 0. And that's going to be 3 over 2. Okay. Now I'm going to find that angle. So remember, to find that angle, I'm going to say tan. Okay. Remember, can I just show you why? Because if you want to find that angle, it's opposite over adjacent, and that's tan. Okay. So tan of that angle of 3 over 2. Press on your calculator, make sure it's on degrees. So press, I just want to see mine is on radians. Okay, now it's on degrees. So shift, tan bracket. 3 divided 2, close the bracket, equals. So I get that angle is 56. Make it 2 decimal places, 0.31. Okay, now I do exactly the same with the other point. Okay, so I'm going to say gradient of tangent at Q, and that's going to be 1 and 2. Okay, and then I'm just going to substitute. Now I substitute the 1 in. So it's 2. Look always at your original. 3, 1 plus 1. Just move up. And it's 3 over 2. And that's 4. And if I just, it's going to be 3. 2 times 2, because that's 2. So it's 3 over 4. And now I'm going to say, I'm just going to do it here. Tan of the angle, 3 over 4. And again, I press, let's call it, let's make it 1. Otherwise, it's 2, the same symbol. Okay, make it 2. So press shift, tan, bracket. 3 divide 4, close the bracket, equals. And that is going to give me 36.87. Okay, and then I'm just end out by saying acute angle between the tangents. And that is going to be 56.31 minus 36.87. And that is going to give me an answer to 1 decimal place of 19.4 degrees. And that's how I do it. Okay, let's make space for the next one, the last one in this video. Okay, let's just move it down. Oh, that lines, that's always coming. Okay. Okay, let's start. Number 3. The equation of the curve, okay, I always like writing it down first. And then it's almost like it's coming, I see it's to the power 4, everything. Okay, now I start. Find the coordinates of the stationary point on the curve and determine its nature. Oh, this is a straightforward question, but there will be that kind of questions also in the exam. Okay, so I'm just going to differentiate. That's step 1, and it's such an easy formula also. Okay, and I'm going to say at stationary points, dy over dx will be equal to 0. So 4x to the power 3 plus 4 will be 0. So 4x3 equals negative 4. So x3 equals negative 1. And if I take the cube root, then it's just going to be negative 1. Okay, it's just going to, so just going to substitute it into the original there, keep it white. So y is equal to negative 1, 4 plus 4, let's get that pen correct, plus 4, negative 1 plus 9. And that's going to be 1 minus 4 plus 9. And if I move it up, that's going to be 10 minus 4, and that's 6. So therefore, stationary point negative 1 and 6. But now I'm not finished. I must also determine the nature. Now, how did I determine the nature? I'm going to double differentiate. So I'm going to find d square y over dx squared. And now where is my equation? Okay, let's just go and find it there. 4x3 plus 4. So if it's just going to be 12x squared. That's all it's going to be. Now say when, okay, remember what was x? When x is negative 1. So say when x is negative 1, then, move it up, d squared y over dx squared equals 12 negative 1 squared, and that will be 12. And just take note, it's bigger than 0. It's a positive point. So therefore, the stationary point is, here it comes, the opposite, a minimum point. Okay, and that's how you do it.